Hello, 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 everybody, and welcome back to our friendly neighborhood mathematician, Root Beer here. And we're still looking at the 2012 MMC. We're all the way up to question number 7 now. So if you'd like to try this question, by all means, click the first link and get yourself a copy of this question. Give it a try, and then come back and watch the video. In the polynomial equation, x to the 7 plus 3x to the 6 2x to the 5, 4x to the 4, 12x cubed, plus x squared, plus x minus 2. We can write it as x squared plus 3x plus 2 times q of x. I'm going to bet that's a polynomial. Plus ax plus b. Find the values of a and b. Okay. What can we do here? Well, if I take a moment and stare at this, I notice that we've got a pattern of 1, 3, and 2 here. We've got 1, 3, and 2. 4 times 1, 4 times 3. We'd expect 4 times 2 here, but obviously it's slightly off. So I think, yeah, that certainly jumps out, but I think the most obvious thing to do, and I would expect what most people probably did, is they just applied polynomial division, which works a lot like regular division. And in reference to our previous question, polynomials are sort of like bases where you haven't specified the base. We did 6a was we had that b squared plus b plus 2 or something like that. It was a quadratic, and we solved for b. Polynomials set up like this with nice positive integer coefficients. Admittedly, the minus 2 messes that up just ever so slightly. But when it's like this, it's where was I going with that? It's sort of like a base that we haven't specified yet. That's sort of how I like to think about it. But regular division works just fine. We've got places and digits representing those places, so it all works out great. I'll show you what I mean if you've never seen polynomial division, but it's a great thing to try out and get some practice. Yeah, so there's question 6 with the bases, exactly what I'm talking about. Let's get a fresh page. And so we set up, it's like regular old long division, we just have polynomials. And we'll get a remainder, and with q of x will go up here. He's the quotient. And we've got our divisor and our dividend. So we got x squared plus 3x plus 1. X to the 7. In some ways, actually, polynomial division is even a little nicer, because you're not left wondering, did it go in 4 times, or is there enough to get 5 times, that sort of thing. You don't have to worry about any of that. It's 2x to the 5, I think. 4x to the 4? Yeah, 4x to the 4. Now, when you're setting it up, be sure to leave space. If there were like a 0x to the 3, write that in. Don't just skip over it and then do the x squareds here. Fortunately, we don't have that this time. X squared, I think it was plus x and then minus 2. Yep, okay. So what's left on top is going to be a polynomial that we call q of x, and then we're going to get all the way down to the end. We're going to be left over with something, and the nice thing about polynomial division, it'll be of degree less than our divisor here, so it'll be a linear thing, and that's exactly what we want. We want a linear thing left over. Okay, so let's get to our polynomial dividing. And the great thing about it is you take the highest power with its coefficient over here, and divide it by the next power that you haven't used over here. Or strike that, reverse it. So we'll take x to the 7. How many x squareds go in x to the 7? Why, there are x5 many. Okay. Once we've written this with any coefficients that are needed, we then multiply through. So x to the 5 times our divisor here, we get x to the 7, plus 3x times x to the 5 is 3x to the 6. Plus 2 is 2x to the 5. And then, like regular division, we subtract. Okay? We get nothing, nothing, and nothing. And then we bring down our next It so happens that we got nothing. You'll see we don't always just clear and then bring things down. All right, so now 4x to the 4, that's the next power we haven't used. Divide that by x squared, and we get 4x squared, so we'll put that over the x squared. And now we multiply through. 4x squared, we get 4x to the 4, and then plus 12x cubed plus 8x squared. We'll have to bring these guys down as well because we have to subtract. We get nothing there, and then x squared minus 8x squared. That's negative 7x squared. Now we haven't used this power. We'll bring some other stuff down with it. Now, negative 7x squared, divide that by x squared, and we get negative 7. So we multiply through, minus 21x, and then negative 7 times positive 2 is negative 14. Subtract these guys, we get nothing. X minus negative 21x is 22x, and then negative 2 minus negative 14 is negative 2 plus 14. So that's going to be plus 12. Okay. So what this really represents is exactly what we wanted it to. So just like when you do 22 divided by 7, you get 3 here, and you get a remainder of 1 down here. And you can rewrite and say 27 is 7 times 3 plus our remainder of 1. Same thing works here. We had x squared plus 3x, our divisor, times whatever we got on top, our q of x. So x to the 5 plus 4x squared minus 7 plus whatever was left over. So that'd be 22x plus 12. That's our a, that's our b. A is 22, and B is 12. Okay, so not as complicated as one might initially think. Okay, now I'm guessing if you tried this one, you probably either knew polynomial division or gave up. Now, I think there's probably one or two other ways you could sort of coax an answer out of there. But I think this illustrates that if you didn't know polynomial division, you've seen it once now, I would say go look it up because it's a great technique. It's a fantastic thing to know. Maybe I'll make a video on that in the future at some point because I've been thinking about trying to just make videos on some techniques. But there we have it. A is 22, B is 12, and that was all, right? Let's go back and check. I think that's all we needed to do for 7. Yep, just find the values of A and B. Boom, we're done. So we got 8, 9, and 10 left to go. In the next video, we're taking a look at question number 8.